Welcome to Get Your FRQ On. This question is from 2005. It's Form B, question 3, and it is calculator active. In the question stem, we've got a particle moving along the x-axis with a given velocity function. The function is valid for values of t between 0 and 5, and we are given that the particle is at position x equals 8 at time t equals 0. In part A of this question, we are asked to find the acceleration of the particle at time t equals 4. So let a of t equal v prime of t be the acceleration of the particle. Then the acceleration of the particle at t equals 4 is given by a of 4 equals v prime of 4. And this is a calculator active question, so we will use our calculator to calculate v prime of 4. A of 4 equals v prime of 4 equals 5/7. So we can conclude that the acceleration of the particle at time t equals 4 is 5/7. In part B of the question, we are asked to find the time t in the interval from 0 to 5, where the particle changes direction, and to identify intervals where the particle is moving to the left. So the particle will change direction when v of t is equal to 0 and changes sign. And the particle will travel to the left when v of t is negative. V of t equals 0 implies that t squared minus 3t plus 3 equals 1, which implies that t squared minus 3t plus 2 is equal to 0, and this implies that t is equal to 1 and 2. So to answer the first part of the question, the particle will change direction at t equals 1 and 2. For the second part of the question, v of t is negative implies that t squared minus 3t plus 3 is less than 1, which implies that t squared minus 3t plus 2 is less than 0, which implies that t is between 1 and 2. So the particle is moving to the left when t is between 1 and 2. In part C of this question, we are asked to find the position of the particle at t equals 2. The position of the particle at t equals 2 depends on the initial position and the velocity function v of t. X of 2 equals x of 0 plus the integral from 0 to 2 of v of u du, which is 8 plus the integral from 0 to 2 of the natural log of u squared minus 3u plus 3 du. This is a calculator active question, so we will use our calculator. X of 2 is 8 plus the integral from 0 to 2 of natural log of u squared minus 3u plus 3 du, and that turns out to be 8.369. In part D of this question, we are asked to calculate the average speed of the particle over the interval from 0 to 2. The average speed of the particle is not dependent on the direction of the particle's motion, so we must integrate the absolute value of v of t. The average value can then be calculated by looking at 1 over 2 minus 0 times the integral from 0 to 2 of the absolute value of v of t dt, which is 1/2 the integral from 0 to 2 of the absolute value of natural log t squared minus 3t plus 3 dt. And again, this is a calculator active question, so we will use our calculator. 1/2 the integral from 0 to 2 of the absolute value of the natural log of t squared minus 3t plus 3 dt is 0.371. So the average speed of the particle is 0.371. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.